Today, our topic is ionic radii in periodic trends in properties in periodic classification of elements. Unit 8, Chapter 8. In the last video, you have seen about the atomic radius, and now we're going to see the ionic radii. So, the ionic radii means the distance from the center of the nucleus of the ion up to the point where it exists, its influence on the electron cloud of the ion. So, the center of the nucleus to the influence on the electron cloud of the ion. So, the center of the nucleus distance and where the electron cloud will exist. So, the electron cloud exists of the ion. That is called ionic radii. You all know that ions are formed when an atom loss or gain of electrons. So, we all know the ions are formed when the electrons is gained or lost during that time in the atoms. Okay, the ions are formed. When the ions are formed, the loss or gain of electrons in the atoms takes place. That time the ions are formed. When a neutron, that is when a neutral atom loses an electron, it becomes positive charge. That is called cation. The gain of electron by a neutral atom forms a negative charge. That is called anion. So, a neutral atom of an electron loses that is when a neutral atom loss an electron, it becomes positive charge. Then that ion is called cation. If an neutral atom gains an electron, it becomes negative charge, and that is known as anion. So, the size of the ions is important to determine their behavior in the solution and the structure of the ion solids. So, the size of the atoms, how the size is determined based on the behavior of the solutions and the structure of the ionic solids. So, if they are in the solution or in the solid, you can determine the size of the ions. And you can see the relative radii, we will discuss later. This one. The size of the cation is always smaller than its corresponding neutral atom. But the anion is larger than the neutral atom. So, the size, if you talk about the size of cation and anion, the cation size is smaller than the neutral atom. Same ways, the cation size is smaller than the neutral atom, and the anion is larger than the neutral. So, cation is smaller and anion is larger than the neutral atoms. And you must know it. As the positive charge increases, the size of that cation decreases. So, the positive charge increases, the cation size will decreases. And the negative charge increases, the anion increases. So, you must keep it this point in your mind, this point. So, positive charge increases, cation size decreases. Negative charge increases, anion size increases. For instance, lithium and sodium lost the single electron from their outermost energy shell to form cation. So, lithium and sodium, they loses their single atom where from the outermost energy level. So, the outermost energy level, they lose one atom. That is, who loses the lithium and sodium. Due to that, for what they lose the electrons? To form cation. Okay. The ions so formed are smaller because the remaining electrons are at the inner cells and attracted more strongly by the nucleus. So, the ions are smaller and the remaining electrons in the inner cells attracted more strongly by the nucleus. Why they are So why the ions are, that is, the ions are smaller. Why they are smaller? The electron in the inner cells attract more strongly by the nucleus. So the electrons in the inner cells are attracted more strongly by the nucleus. Because of that, the ions are smaller. Fluorine and chlorine become negative ions by gaining an electron. So by gaining an electron, fluorine and chlorine becomes negative charge. When the electrons are added, the charge on the nucleus is not great enough to hold the increased number of electrons as closely as it holds the electrons in the neutral atom. So the electrons are added. Due to this, the nucleus cannot able to hold the greater enough electrons. So because it has to increase the number of electrons, they are holding in the neutral atoms. The electrons holding in the neutral atoms. So as seen in atomic radius, ionic radii also decrease along the period from left to right and increases down the group. So because of the adding and remove, that is adding and loss of electrons, that as the atomic radius, in ionic radius also, if you see on in the periodic table, it decreases from left to right. The ionic side, that is the ionic radius, decreases from left to side in the period, and in group it increases from it increases down, that is it increases from top to the bottom. And you can see here in this one, what for example they had given this, no, the ionic radii, and that is the loss and gain of electrons. So lithium and sodium had lost the electrons to get positive charge to become cation. Okay, you can see the positive charge here. Okay, so here they loses. But the fluorine and the chlorine gain the electrons. So okay, they gain the electrons and they are negatively charged. You can see the F minus and chlorine, and you can see the number here 156 to 90. It was reduced. That is loss of electrons, that much has taken place. And same way 186 to 116 in sodium. And here in fluorine 69 to 1119. And chlorine 91 to 167. So like this, the gain and loss of electrons takes place based on the cation and the ion. It is depends on the radius. So the ionic radius. Thank you for watching the video. Give a thumbs up, share and subscribe to Science Easy Tech channel.